Hello everyone, this is Aditya and today study conformal transformations in a one go. But for that, please do like, share, subscribe my channel and be supportive. Now let's start. Before starting, I need to tell you all that when I had made the complex analysis one shot, I had told you that I will cover transformations and complex integrals together. But when I was making the notes for this lecture, I felt that if I cover them together, then it will like too lengthy lecture. So I have made conformal transformations in a different video and complex integrals in a different one shot so that every topic can be covered. Now let's start. So first of all, let's understand what do we mean by mapping. Mapping. So for example, if I give you a simple function fx is equal to 2x, right? Okay. So suppose these are set A and this is our set B, right? Suppose I give the input as 1, then what output should come? It should come like 2 because fx is equal to x, okay? If I give 2, the output should be 4, right? And if I give 3, it should be 6. So they are linked like this, right? So this is a mapping where fx is equal to 2x, right? So if this is x, this is 2x, right? So this is the relation between y and x, right? Y is equal to fx, correct? Now similar mapping is used in complex numbers also. Complex functions. Let's learn them also, right? And yeah, one more thing, if I say you to graph this, then it is very simple. You draw a y-axis and an x-axis and you draw it like this, right? This is y is equal to 2x, right? Very simple. Now similar we'll be applying complex functions too. Let's see that. Now let's assume a very simple complex function f of z is equal to z square. Now we all know that z is equal to x plus iota y, right? So z is equal to x plus iota y, correct? Where I is equal to square root of -1. And I would recommend first of all watch the complex analysis one shot, then you will be able to understand everything better, right? So z is equal to x plus iota y. I will give the link in description or in comment section, whatever you want, I will give, okay? So f of z is equal to x plus iota y whole square, right? Just open this term, you will get x square plus 2x times iota y plus iy whole square, which is equal to x square minus y square, right? Plus I times 2xy, right? This is equal to f of z, right? Now instead of writing f of z every time, what we do is that we write it like w. We set it equal to w basically. So basically we will be representing f of z as w, okay? Now we all know that complex function is equal to u plus iota v, correct? Where u is a function of x and y and v is also a function of x and y, right? Hence we can equate this expression to this. So we'll have u of x comma y is equal to x square minus y square, and we have v of x comma y is equal to 2xy, right? So we have this relation. Now how can we represent this stuff on graph? Because we can easily represent like this on mapping like this. So this is our z and this is f of z, or it is w, right? Suppose it is equal to 1 comma 1, right? So if it is 1 comma 1, then we will simply substitute over here 1 comma 1. So 1 square minus 1 square is equal to 0 plus 2 times this quantity, it will be equal to 2i, right? It will be equal to 0 comma 2, right? This is u value and this is v value, right? So this is linked like this. So it is basically f of z is equal to z square. You can check it also. 1 plus iota whole square is 1 square plus 2i plus I square, which is equal to 2i, right? Hence it is 0 comma 2, right? Where we all know that I is along the vertical axis and real is along the horizontal axis, right? Hence it is this, right? So we can represent all the points like this. But how can we plot this on a graph? Well, we all know that this is two-dimensional because it has two axes and this also has two axes. It means that to represent its graph we will need a 4D plane system, but it is not possible. Hence what we do is that to represent such kind of stuff we use two graphs, two plane. One, the z plane, this is y and this is x, right? Okay. So in this we represent the values of the z plane, that is x plus iota iota y, and in the other plane we say it as w plane. We set the value of u and v, and accordingly we draw the graphs. So corresponding to some value over here, we will be having some value over here also, right? For example, we had used this value, right? So this is 1, this is 1, right? So this was the point 1 comma 1, this one, okay? So it represents to 0 comma 2 in this w plane, right? So this is 0, this is 1, and this is 2, this is 1, and this is 2. So this is 0 comma 2. So this is how you will represent it, right? So basically it is a 4D plane, but of course we can't draw 4D, so that is why we draw it separately, right? Understood? Okay, so now let's move to some further concepts. Now let's define conformal mapping, right? Conformal mapping. So let me define a very simple words. For example, if you have a curve like this, in the z plane you have two curves starting from this point. Suppose it goes like this maybe, or the other one goes something like this, maybe, whatever be it. Suppose this is C1, this curve 1, and this is curve 2, right? And there is an angle in the anti-clockwise direction as theta, right? Okay. And suppose corresponding to these curves, suppose this is equal to f of z is equal to some value, okay? So some whatever be it, okay? This is z plane. So it depends upon some function. W is equal to f of z, right? We know this. So this is our z plane, right? This is z plane, and here we have w is equal to f of z. This is w plane, right? This is u, and this is v. And suppose corresponding to C1, suppose we have a curve like this, suppose maybe like this, and suppose corresponding to this, suppose name it as P1, and suppose corresponding to C2 we have a curve like this. This is suppose P2, right? Now if this angle is alpha, right? Okay, so this is equal to theta and this is equal to alpha, right? Now to be conformal transformation, it must follow that the magnitude of alpha must be equal to magnitude of theta, and they both should be along same direction. In this they both are along anti-clockwise direction. But suppose if C1 corresponding P1 over here and it was P2 over here, then the angle would be like this. It would be clockwise direction, right? So in this case, even if the magnitude is equal but the direction is different, so it is not a conformal mapping. It is then called, so for being conformal, it must have same magnitude and the direction should also be same. That is, if it is along anti-clockwise direction, it should be anti-clockwise only, both the angles, right? Direction should be same, right? And if magnitude is equal but the directions are opposite, then we say direction opposite, right? Opposite, then it is called isogonal mapping. Okay, so this is isogonal mapping, and if it is like this, this is P2 and this is P1, then it is conformal mapping. Okay, provided that this condition is satisfied. Okay, so these are some of the basic conditions. It is just for an introduction. Now we'll be moving to different types of transformations. Let's understand that. Different types of mapping. Transformations, we can say. Transformations or mapping, whatever you want to say. Transformations, okay? So the first one is translation. The second one is magnification. The third one is rotation, and the fourth one is inversion, right? Now I know that it is a bit confusing that I already wrote the term over here, but you will understand in a few moments. Translation, suppose there is a curve in z plane, suppose like this is x and y. Okay, now over here, now if in the w plane, suppose it moves like this, suppose it comes over here or anywhere, suppose over here it can come, maybe this is v, this is u, this is w plane. So what's exactly happening over here is that we have just picked this curve and we have placed it over here without changing its magnitude or anything, right? So such kind of transformation is called a translation, right? And it is given as w is equal to z plus alpha, where alpha belongs to complex number, right? So this is called translation, right? Okay, suppose if it was a rectangle like this, then suppose I placed it over here, this is a translation. Okay, now let's understand magnification also. Suppose this was the rectangle, at the same place if I just increase the size of this rectangle, then this is called magnification, right? It is given by w is equal to alpha z, where alpha belongs to real number this time. Okay, and yeah, of course, if alpha is greater than 1, then there will be magnification. If alpha is less than 0, sorry, less than 1 and greater than 0, then it will be shrinking, right? Okay, okay, so now let's see rotation. Well, suppose this is the rectangle and I rotated it. Well, I should now place it over here so you can understand it better, right? So suppose it is over here. Now I rotate it by some angle, suppose alpha, right? So what will happen is that it will be like this. Yeah, suppose I rotate it in anti-clockwise direction like this, suppose like this. Okay, this is angle alpha, right? So this is called rotation, right? So rotation, it is given by w is equal to e to the power I alpha times the quantity z, right? Now one question is that will the magnitude change or not? Well, we all know that z is equal to r raised to the power r into e raised to the power I theta, correct? Okay, hence we have w is equal to e raised to the power I alpha times r e to the power I theta, which is equal to r times e to the power I times alpha plus theta. So we can clearly see that just the angle has changed, the argument has changed, but the magnitude is still same, right? So its magnitude and this magnitude will be same. Of course, it is like too big, so I should also draw it like big only. Yeah, now at least they are looking of same size. Now inversion is like a bit complex, so I don't think so I should discuss it right now, but if I tell you it is w is equal to 1 upon z, so in this case the magnitude becomes 1 by r, because z is, of course, it is equal to r times e to the power negative e to the power I theta, right? So in this case w will become 1 upon r e to the power I theta, correct? Okay, hence what we'll get is that the magnitude is 1 upon r and the argument is what? E to the power negative I theta. So argument is negative theta now. Okay, correct? So suppose if it was something like this angle is theta. Of course, I'm not talking about the magnitude right now. So it will be somewhat like this in negative theta, right? Of course, this is not any accurate graph for now, but negative theta is along this axis, right? In the clockwise direction. And this is along anti-clockwise, correct? Okay, so this was the basic introduction. Now we will discuss each and every transformation in detail, right? So let me erase this, then we will see. So first transformation is translation, transformation, transformation, okay, or mapping. Okay, so it is a mapping where w is equal to z plus alpha, right, where alpha is a complex number, right? So let's understand it using a question. What is the image of rectangular region? This is a very basic question. I think everyone discussed this type of question, right? These are very basic questions which you will find everywhere, right? In your exam also you'll find such kind of questions, right? There is These are very common questions actually, right? So of rectangular region of the z plane bounded by the lines x is equal to 0, y is equal to 0, and x is equal to 1 and y is equal to 2, right? Under the transformation w is equal to z plus 2 minus I, sorry, what I have written, z plus 2 minus I in w plane, right? Okay, so I think that you all know how to draw a graph, right? If you don't know, let me explain it. So let's solve this question. So this is our z plane, x and y, these are the axes, these are the axes, this z plane. Now we have to find the image of rectangular region of z plane bounded by the lines x is equal to 0 and y is equal to 0 and so on. Okay, yeah. So x is equal to 0, y is equal to 0. So what is x is equal to 0? Well, it is this axis, correct? And what is y is equal to 0? Well, it is this axis, correct? What is x is equal to 1? Well, it is this, right? Okay. What is y is equal to? It is this. So basically this is the region. Okay. So let's name the points. Well, we don't need it actually. Okay. So x is equal to 0, y is equal to 0, x is equal to 1 and y is equal to 2, right? Now we know this transformation that w is equal to z plus 2 minus iota, right? So z is equal to, sorry, w is equal to z plus 2 minus iota, right? Now we all know that z is equal to x plus iy, right? So it is equal to x plus iy plus 2 minus I, right? Okay, correct. Now we can say it is equal to x plus 2 plus I times y minus 1, correct? Right? Now what is w? W was equal to f of z, which is equal to u plus iota v, right? So it is u plus iota v, hence u is equal to x plus 2 and v is equal to y minus 1, correct? Right. Now what are we going to do? Well, first of all we will draw a u v axis, that is w plane, right? Now we know these values. So when x is equal to 0, u is equal to 2, right? This is the line, u is equal to. When y is equal to 0, v is equal to negative 1, right? Okay. When x is equal to 1, then we have u is equal to 3, okay? And when y is equal to, then v is equal to 1, correct? 2 minus 1 is equal to 1, right? Okay, so why am I calculating the value of u and v? Well, we are just transforming it from here to here. We are basically finding its image, right? So if we are finding the image, we should know that x correspond to what in u and y correspond to what in v, right? So we have these 4 lines actually, right? So now we can just plot it very easily. So this is 0 and let me erase this. This is 1. Suppose this is 2. This is 3. We have to go till 3 and we don't need to go there in negative. And this is negative 1. This is negative 2. This is 1. This is 2 and this is 3, right? Now when u is equal to, what is this line? It is this one, okay? U is equal to 2, correct? Okay. Now v is equal to negative 1. V is equal to negative 1 is this line, okay? Now what is u is equal to 3? It is this one. It is this line, okay? This one. Now what is v is equal to 1? It is this line. So this is the region. Okay, so this is the image of this, right? After transformation, that W is equal to Z plus 2 minus iota, right? Now I think you should be asking me a question right now, that how can we say that it is conformal mapping? Well, it is very simple to say, because it is just a linear function of Z, and in linear function the angle is not changed, if you can understand it from this. It is very much obvious that angle is same in both the cases. That is, the angle in this, the angle, whatever be the angle, because if you remember in the conformal transformation, I have defined how a transformation is conformal transformation if the angle is same and it is in the same direction, right? So this is 0 comma 0, right? This is which point? This is what? This is 1 comma 0, and this is 1 comma 2, and this is 2, and this is 0 comma 2, right? So this is A, this is B, this is C, and this is D, right? Now corresponding to this, what points we have over there? Well, when x is equal to 0 and y is equal to 0, they intersect, we got the point A. So when x is equal to 0, y is equal to 0, it means that when u is equal to 2, u is equal to, and v is equal to negative 1 coincide, that is this is A dash, right? This is A dash. Similarly over here, when y is equal to 0 and x is equal to 1 intersected, then we got the point B, right? So when x is equal to 0 and y is equal to, 0, sorry, x is equal to 1 and y is equal to 0, this one, okay? So u is equal to 3, and v is equal to negative 1. So this is the B dash point, right? Okay, and again this will be C dash and D dash, right? So it means that it is in anti-clockwise direction and this also in anti-clockwise direction, right? So angle is also same and the direction is also same, right? Understood? Okay. Now let's understand this question. Image of triangular region, triangular region, region of Z plane bounded by x is equal to 0, y is equal to 0, x plus y is equal to 1, and the transformation is W is equal to Z plus 1 plus I, right? So this is the transformation which we are given, and of course it is a translation transformation, and we have to find the image of the triangular region which is formed using these lines. So this is our Z plane, x and y, and we are given x is equal to 0, that is y axis, and we are given y is equal to 0, that is x axis, right? And x plus y is equal to 1, which is this line, correct? Okay, so we have to basically find the transformation of this triangle, this one. Okay, so suppose this is A, this is B, and this is C, right? Okay, so here we have three curves, this one, and this one, right? Okay, so when you find its transformation, what you will get, let's see that. So again W is equal to Z plus 1 plus I. Now it is equal to x plus iota y plus 1 plus I, which is equal to x plus 1 plus y plus 1 I, right? U plus iota v. So u is equal to x plus 1 and v is equal to y plus 1, correct? Okay, now notice one thing, that here we have okay, these two are just points, but this is a straight line. So how can we use it to form our equation over here? Well, first of all, let's use x is equal to 0, then we will have u is equal to 1. Okay, u is equal to 1, and when y is equal to 0, we have v is equal to 1, right? Now when x plus y is equal to 1, then what will have? Well, just add these two equations. What you will get? You will have u plus v is equal to x plus y plus 1 plus 2, sorry. Hence u plus v is equal to 1 plus 2, that is 3. Hence u plus v is equal to 3, right? Now just plot it, right? This is u, this is v, this is w plane, right? Now what is u is equal to 1? Well, u is equal to 1 is this, right? Okay. And what is v is equal to 1? It is somewhere over here, right? And what is u plus v is equal to 3? Well, now this is a tricky part. So let me write the points over here, right? So we have to draw this, right? I think it should be a bit close because of course it is a bit big graph. So this is 1, this is 2, this is 3, this is 1, this is 2, this is 3. So this region and this region, right? So we have got this graph. So this is basically u is equal to 1 and this is v is equal to 1. Okay. Now what is u plus v is equal to 3? Well, it will go like this. So it is this region, right? And again, when you will see the direction, it is again in anti-clockwise direction. It's your job to check. So this is the transformation, the translational mapping over here, right? Of this curve, of this region, I mean. Okay. So I hope so that it is clear. Now let's move to magnification translation. Okay. Sorry, magnification transformation. Magnification transformation. Magnification transformation. Transformation or mapping, whatever you want to say, mapping or transformation over here. Now again I defined it like w is equal to what? W is equal to alpha times z, where alpha belongs to real number in this case. Okay, right? Hence we can either prove it over here also, or whatever you can do. Alpha x plus iota y, right? Hence it is equal to alpha x plus iota alpha y. Hence we have u is equal to alpha x and v is equal to alpha y, right? Similarly, you can do it over here, over there also in translation also. You can just instead of z plus alpha, you could have checked it like this also: x plus iota y plus some a plus iota b, right? That is also this is the general form actually when you solve it, right? But it's okay if you don't want to use like this. You can just understand it using a question, right? That whatever values are given in the question, you can just use them to place in place of a and b, right? So it is not necessary that you prove the general formula, right? General form, right? So it's okay. So this is also just a redundant part. I just told it like this. Okay. So let's erase this and this also. Okay. So let's see a question as the question which I discussed before only. The rectangular region only. This one. This is x-axis and this is y-axis. And this was x is equal to 1 and this was y is equal to 2, right? The previous question only which we were discussing of rectangle, right? That is only, this is z plane, and in this the transformation which we are given is that w is equal to 2z, right? Now so w is equal to times x plus iota v, hence u is equal to x and v is equal to 2y, right? Okay, hence what we have now, x is equal to 0, y is equal to 0, x is equal to 1 and y is equal to 2, right? Just like in previous case. Hence u is equal to 0, v is equal to 0, u is equal to 2 and v is equal to 4, right? Now just draw the uv plane, that is w plane, right? And in this just plot this. So it will be this region, and u is equal to 2, that is if this is 1, this is 2, so this region, and this is 1 2 3 4, this, so this region. And again if you check, it is along anti-clockwise direction only, right? Okay, so I think that it is clear that how we do magnification. We just use the same concept which we were using in translation transformation also, using the concept that z is equal to x plus iota y, and then we frame a relation between u and x, basically u and x and y and v and x and y, and then we formulate all that, and then we substitute the values at different points which we are given, and using the intersections we take the image in w plane, right? That is the basic concept. Now let's see what's next. Well, you can try the triangular one on your own, right? You can just try that one on your own using this function only. Suppose w is equal to 2z. If you will have any doubt, I can make a video on that, okay? But you should give it a try, that one. X is equal to 0, y is equal to 0, x plus y is equal to 1, right? This one. So you can give it a try, and if you get any doubt, just let me know in the comment section. I will make a video on that, okay? So this you can do for homework, right? The concept will be same, okay? So now let's move to rotation. Let's study rotational mapping or transformation, okay? So in this we had already find that w is equal to e raised to power I alpha times the quantity z, right? Okay. So we all know that z is equal to e raised to power I theta times r, the magnitude. Hence w is equal to r e to the power I times theta plus alpha, right? So from this we can say that the magnitude is constant in this, right? Okay. Just it has rotated. So let's just again use that question of rectangle to understand this also. This is 0, this is 1, this is 2, and this is 1 comma 2, right? This is x-axis, this is y-axis, and this is z-plane, right? Now suppose we are given a transformation in this as w e raised to power I into pi by 4 times z, right? Okay. Now here you have two methods. The first one you already know this. You can just rotate it by 45 degree. That is it. Okay. That I won't discuss. I will discuss the complete method over here. That is, we can write e raised to power. We know that e raised to power I theta is equal to cos theta plus I sin theta, right? Okay. Plus I sin theta. Hence, e raised to power I into pi by 4 is equal to cos of pi by 4 is equal to 1 by root 2, right? Plus I into 1 by root 2, right? Okay. And I know if it is getting a bit tough for you, then please do check out the complex analysis one shot, because of course if you don't know complex functions, then how you can discuss all this, how you can understand all this, I mean. So watch that video first of all, then you should move to this one, okay? So this is equal to this. So we have 1 by root 2 plus I by root 2 into the quantity x plus iota y, right? Hence now just multiply this stuff. What you will get? X by root 2 plus I into y by root 2 plus xi by root 2 minus, right? So we have x by root 2 minus y by root 2 plus the quantity I times x by root 2 plus y by root 2. It is equal to u plus iota v, correct? So x is equal to x by root 2, sorry, u is equal to x by root 2 minus y by root 2, and we have v is equal to x by root 2 plus y by root 2. Just check it once. If you are getting exhausted from seeing all this, just try to understand. What I have done is I have just used the Euler's identity, Euler's formula, and then I have just formatted all this into this equation, and then I just evaluated this, and I got this from comparing the coefficients. Okay. Okay, so now let's see this. So we have this expression. Now we have x is equal to 0, y is equal to 0, and x is equal to 1 and y is equal to 2, right? Now there is a problem. We have two variables over here in one equation, in both the equations, and we have just points over here. Then how we can do? Well, just eliminate them. I mean, when you add them, you will have u plus v is equal to x2 by this quantity, and when you subtract v minus u, what you will get? You will get 2y by root 2, right? Okay, so it is equal to x root 2 and this is equal to y root 2, right? Okay, now everything is clear. Now what you can do is that sorry, yeah, x is equal to 0, y is equal to 0, x is equal to 1, y is equal to 2, right? Okay, so when x is equal to 0, what we have? We have u plus v is equal to 0, u plus v equal to 0, right? And when we have y is equal to 0, we have v minus u is equal to 0. And when we have x is equal to 1, what we have? We have u plus v u plus v is equal to root 2, right? And when y is equal to, we have v minus u is equal to 2 root 2. V minus u is equal to 2 root 2, right? Okay, are you understanding it or not? Okay, so let me raise this, then we'll plot its graph. Okay, so let's see it. So this is UV plane, W plane, right? Okay, so V minus U is equal to 0. It means that this is the line at 45 degree, right? Pi by 4, because of course the angle between y is equal to, the angle in this case is equal to 45 degree. We all know that this is inclined by 45 degree, right? This line. So we have this, and how does this v minus u look? That is v is equal to negative u look. It looks like this, passing through origin. Now let's see how does v minus u is equal to root 2 look. Well, v is equal to u plus 2 root 2. Well, when v is equal to 0, u is equal to negative 2 root 2. Hence it will be somewhat over here, negative 2 root 2. And when u is equal to 0, it is over here, 2 root 2, right? So it looks like this. Okay, correct? Okay. And when now let's see this one, v is equal to negative u plus root 2. So when u is equal to 0, v is over here, right? Somewhat over here. Okay, it should be in the middle, I guess, somewhat over here. And when we have u is, that is v is equal to 0, then we have u is equal to root 2, somewhat over here, right? So it is going like this. So it is basically this region. Okay, so after transformation it looks like this after rotation, right? Inclined by 45 degree. Understood? So what I've done, and again this is, if this is a b c d, right? So the angle and the rotation and the direction is same, right? Hence it is again conformal transformation. Okay, so let's move to the next topic now, inversion, right? Let's erase this. And yeah, try the triangle one on your own. Now let's study inversion transformation. Inversion transformation. Okay. So again, W is equal to 1 upon Z, that is 1 upon R e raised to power I theta, which is equal to 1 upon R e raised to power I negative theta, right? Okay. So let's study it using a question first of all. And yeah, let's study it using a question. But one more thing, we can also write it like this: 1 upon Z is equal to 1 upon Z times Z bar, and over here Z bar. Okay, so it is equal to x minus iota y divided by, that is the mod Z, that is equal to x square plus y square, which is equal to u plus iota v. Hence u is equal to x by x square plus y square, and v is equal to negative y by x square plus y square. And this is a very helpful information, so we should remember this. You can easily prove it also, but it is better to remember it. Okay, so from here we can say that u square plus v square is 1 upon x square plus y square, right? It is very much helpful, right? You can prove it also, just square it and add it, right? You will get it. Okay, so let's erase this and let's discuss it using a question. So the question states, image of circle x square plus y square is equal to 4 by under the transformation w is equal to 1 upon z, right? So we have to find its image, right? That's it. So x square plus y square is equal to 4y. So this is the z plane equation, right? So we can clearly see that it is the equation of a circle, right? Hence we have x square plus y square minus 4y is equal to 0. Let's complete the square. So we have x square plus y square minus 4y plus 4 is equal to 4, right? Hence we have x square plus y square, this y square, that is y minus 2 whole square, right? This is equal to 4. So we have x square plus y minus 2 whole square is equal to 2 square. Check it once. I hope so that you remember circle, what you studied in that. So its center is 0 comma 2 and its radius is equal to 2 units. Okay, so this is a circle. Okay, Now the transformation is this, right? So we have the transformation as u is equal to x upon x square plus y square, and v is equal to negative y by x square plus y square, right? Well, this is one way to write it. What is another way to write it? Well, I can also say that z is equal to 1 upon w. We can say this, right? So we have x plus iota y is equal to 1 upon u plus iota v, right? And similarly, when you will rationalize this, you will get x is equal to u by u square plus v square, and y is equal to negative v by u square plus v square. So depending upon the criteria, I mean depending on the question, if you have to use this, then use this. If you have to use this one. Okay. So over here I have an equation in x and y. Hence we will use this one. So just substitute over here. What is x square plus y square? Well, u square plus v square was equal to 1 upon x square plus y square. Similarly, x square plus y square is equal to 1 upon u square plus v square. So it is equal to 1 upon u square plus v square is equal to 4. What is y? Y is equal to negative v divided by the quantity u square plus v square. So this and this gets cancelled. Hence, we get the value v is equal to negative 1 upon 4. So in the w plane, it looks like this. This is negative 1 upon 4. So it is a straight line parallel to the u axis, right? This is the w plane, right? Okay. Now, how you draw this curve? I mean this circle. Do you know how to draw a circle? Well, try it on your own, okay? Try to draw the circle on the xy plane, okay? On the z plane, okay? It is a very simple thing. You can use the help of some graph generators also if you don't remember, right? But it is a very simple thing, okay? I have already made a video on circles, I guess, somewhat. It was like some months back, so you can check out that video also. So it's your homework. Try to draw the graph of circle. If you don't remember, it is a very simple thing, okay? So now let me raise this. Now there are two theorems related to inversion transformation. Let's discuss them. Theorem 1, right? So what is it? We will prove it. So I will write in form of question. Show that transformation w is equal to 1 upon z maps a circle in z plane to a circle in w plane, or a straight line if the former passes through origin. Well, what does it mean? Well, it means that we have to prove that under the transformation w is equal to 1 upon z, it maps a circle in z plane. If it maps a circle in z plane, then in w plane it is either a circle or a straight line. If it passes through the origin, the circle passes through the origin, for example like this or whatever, then it will be a straight line. And if it does not pass through the origin, then it will be a circle in w plane also. Let's prove this. Well, what's the general equation of a circle? It is x square plus y square plus 2gx plus 2fy plus c, right? Plus c is equal to 0, right? Okay. Now we all know that x square plus y square is equal to 1 upon u square plus v square. We remember it. So it is 1 upon u square plus v square plus 2gu by u square plus v square minus 2fv by u square plus v square plus c is equal to 0. Hence we have 1 plus 2gu minus 2fv plus c times the quantity. Now notice that this is a circle if c is not equal to 0, and it is a straight line if c is equal to 0. Why? Because what makes a circle? This term u square plus v square. If this will become 0, then of course it will be a straight line. And if c is equal to 0, it implies that this expression is x square plus y square plus 2gx plus 2fy is equal to 0, right? So notice that x comma y is satisfying this equation always. X comma y equal to 0 comma 0, it will satisfy this equation always, because x is equal to 0, y is equal to 0. 0 plus 0 is equal to 0. Hence it is passing through origin if c is equal to 0. Hence if it passes through origin, then it is a straight line, and if it does not pass through origin, then it is a circle, right? Understood the theorem 1? Okay. So now let's move to the next theorem. Okay. Now let's discuss the second theorem, theorem 2. Theorem 2, what it states, show that transformation w is equal to 1 upon z maps a line in z plane. If it maps a line in z plane, a straight line in z plane, to a circle or a straight line in w plane, right? Okay, whatever be it. Okay, so let's understand its proof. So what is the equation of a straight line? Well, it is ax plus by plus c is equal to 0, right? Now u square plus v square minus b v divided by u square plus v square plus c is equal to 0, right? So au minus bv plus c times u square plus v square is equal to 0. Now if c is equal to 0, then of course it is the equation of a straight line. Au minus bv is equal to 0, and if c is not equal to 0, a straight line, then it is a circle, because we have u square plus v square term over here. So I think here should be in w plane, if, yeah, depending upon the criteria, that if former passes through origin. Why? Because again, if c is equal to 0, then ax plus by, so 0 comma 0 will satisfy this thing, right? Understood? Okay, so now let's erase this, and now let's move to some next topic. Okay, let's see. Now let's study linear mapping, linear transformations. Linear transformation. Well, what is a linear transformation? A transformation, it is a combination of translation, magnification, and rotation. So we will study linear transformation now. So its general form is given as z is equal to alpha z plus some beta. Alpha and beta belong to complex number, right? Well, how is it then combination of translation, magnification, and rotation? Well, some complex integers, or this w, some complex function plus a complex number, it is a translation. Okay, now alpha is a complex number, now so it can be written as r e raised to power I theta, where r is a real number and e raised to power I theta is a complex number, right? Hence w is equal to r e raised to power, or I can write it like this, e raised to power I theta, it is the rotation, or I can write it as theta only, because I've used alpha over here, r into z. So this r times z is magnification, and this is rotation, and this translation. So of course it is a combination of these three, right? Okay, so let's erase this, and let's move to some questions to understand this, right? Okay, so let me erase this. So this is the question. So we are given the linear transformation as w is equal to 1 plus I z plus 2 minus I, right? This is the linear transformation. Again we are taking the example of that rectangle, that x is equal to 0, y is equal to 0, x is equal to 1, and y is equal to 2, right? So we have to find its transformation. So again it is very simple. So z plane, it looks like this. This is x, this is y, this is 1, this is 2, this is 0, right? That is it. Okay, so w is equal to 1 plus iota times x plus iota y plus 2 minus iota, right? That is it. Okay, simple. So just multiply it, x plus iy plus ix, x plus iota y, right? This multiplied by this plus ix minus y, right? Correct? I square is equal to negative 1 plus 2 minus iota, right? So we have x minus y plus 2 plus I times x plus y minus 1 is equal to u plus iota v. Hence u is equal to x minus y plus 2 and v is equal to x plus y minus 1, right? Now again here we had just these lines that x is equal to 0, y is equal to 0. We had just one variable, right? Okay. Hence we will just add them just like we did there. So u plus v is equal to what? 2x plus 1 and v minus u is equal to 2y minus 3. 2y minus 3, right? Okay. So now we have this. Let me refill the ink. So we have x is equal to 0, then we have if x is equal to 0, y is equal to 0, x is equal to 1, x is equal to 1 and y is equal to 2, right? Y is equal to 2, correct? Okay. Then what we will get is that u plus v is equal to 1 and when y is equal to 0 we will have v minus u is equal to negative 3 and when x is equal to 1 we have u plus v is equal to 3 and we have then v minus u is equal to 1, right? Okay, see it, right? So now let's plot this. Let me erase this. So this is our u plane or w plane. This is u, this is v, this is w plane, okay? And now we have these lines. So v is equal to u plus 1. So v is equal to u plus 1, right? So it goes somewhat like this, correct? Okay, this is v is equal to u plus 1, right? Okay, and v is equal to u minus 3. Well, it will go somewhat like this, correct? I think I should make it a bit far because of course this point is 0 comma 1, right? So it will go like this. This is 0 comma negative 3, right? I hope so you're understanding what I'm doing. It is just plotting the lines. I hope so that you understand this, okay? And what is v is equal to negative u plus 3? Well, when u is equal to 0, v is equal to 3, right? And when v is equal to when u is equal to 0, then v is equal to 3, right? And when v is equal to 0, then u is also equal to 3, right? So it will be what will be its intersection? This is v is equal to u minus 3. So when v is equal to 0, u is equal to 3. So this is 3 comma 0, right? So it will pass like this. Okay, correct, right? Okay, so now let's check this one. So we have v plus u is equal to 1, that is v is equal to negative u plus 1, right? So when u is equal to 0, then v is equal to this quantity, okay? And when v is equal to 0, then u is equal to positive 1, right? That is somewhere over here, right? 1 comma 0. So it goes like this. So we have got this region, okay? It is inclined at 45 degree. We can easily see because here the coefficient is 1, that is m is equal to 1. Since m is equal to 1, hence tan of 1 is equal to 45 degree. So it is rotated by 45 degree over here and it has moved like this, okay? So we have seen translation also and we have seen rotation also and probably there must have been magnification also, right? Okay, so now let's move to next question, right? Now this is a question in which we have to determine the linear transformation that maps. So determine the linear transformation whatever be the question, that maps the rectangle z1 is equal to 0, z2 is equal to 1 by 2, z3 is equal to I, z4 is equal to 1 by 2 plus iota onto the rectangle w1 is equal to I, w2 is equal to I, w3 is equal to negative 2 plus I and w4 is negative 2 plus 2i, right? Okay, so let's see this one, okay? So basically we have to determine the linear transformation in this case. So we are given a curve in this and we have to determine what linear transformation is bringing that image, right? So let's plot this first of all. So z is equal to 0, z1 is equal to 0, that is 0 comma 0, that is this point, okay? And z1 is equal to 1 by 2, that is over here, 1 by 2 is over here. And z3 is equal to I, that is over here, this is 1. And z4 is equal to 1 by 2 plus iota, right? This one. So this is the basic this is basically the curve which we are given in xy plane or z plane, right? And what is the y plane? Let me draw it like this. Yeah, this is v, this is u, this is w plane, right? So we are given w1 is equal to I, that is uh, over here, right? Because we have 2i also, and we have 2i over here, right? This is 2, this is 1, okay? This is 1 by 2 over here. And we have negative 2 plus I. So negative 2 plus I, so this is 1, this over here. This is negative 2. So negative 2 plus I and 2I, negative 2 plus 2I. So basically this is the rectangle, final rectangle, okay? So which transformation, we will determine that linear transformation which will give this image of z plane. So we can see that it is like rotated by which angle? Well, we all can just see it on our own that if we check this line and this line, right, they both are perpendicular to each other, right? Means it has rotated by 90 degree. Suppose if the angle was like 30 degree or any other angle other than 90 or any other degree, any other angle, then in that case you just find the slope of this one and the slope of this one. Suppose this is like this, then we have this, right? So we can find the angle between them, right, using the slopes, using the formula which we know, the relation between slopes, if you remember, right? In a straight line you should check that one, that how we find the angle using the slopes of line, right? Just check it once, okay? Of lines or curves, right? Both are same, I guess, right? So we know that if we set z to, if we rotate z by e to the power I pi by 2 times the quantity z. If we do rotation, then we will have we will rotate it by like this. So this will become, so when we rotate it, it will become something like this. When it is rotated by 90 degree, it will go like this, right? Somewhat like this. Now we know that this length is equal to 1 by 2 and this is 1, which means that we have to multiply this by 2, right? So we will magnify it, that is we will use magnification. So here 2 into e to the power I pi by 2 into z, right? So it will get magnified. Now we know that this was earlier at origin and we have to bring it to 1, right, along y-axis, along the basically the vertical axis. Hence we will use translation or translation, okay? So 2 e raised to the power I pi by 2 z plus iota, right? This is the value, this is the transformation, this is the linear transformation required, okay? Now of course you can say e raised to the power I by theta is equal to I, so it is basically equal to w is equal to 2iz plus iota, right? Like this. So this is the final transformation which you will get, right? So now let's move to next topic. Now let's study bilinear transformation, and I know that max of you get doubt in this only. So let's discuss it. Bilinear transformations or mapping transformations. Okay. So well, a transformation which is of the form az plus b divided by cz plus d, right? Az plus b divided by az plus cz plus d, right? It is a combination of all four. Translation, it is a combination of all four, that is translation, rotation, magnification and inversion, right? Okay, so hence it is called bilinear. Okay, now let's see a theorem, right? Theorem, bilinear transformation w is equal to az plus b divided by cz plus d is combination of elementary transformation, that is them. These are called elementary transformation. Translation, rotation, magnification, inversion are called elementary transformations. Okay. So how we can prove it? Well, W is equal to AZ plus B divided by CZ plus D. Well, what we can do is that just multiply by CW and divide by A. CW by A, okay? CW by A is equal to A is equal to CAZ plus CB divided by the quantity ACZ plus AD, right? Okay. Now what we can do is that we can arrange it a bit and just solve it. Let me show you. ACZ plus AD minus AD plus CB divided by quantity ACZ plus AD, right? So it is equal to, now this, it will become 1 minus the quantity 1 plus CB minus AD divided by the quantity ACZ plus AD, right? Now just multiply this expression, so you will get W is equal to A by C plus the quantity A by C times BC minus AD divided by the quantity ACZ plus AD, right? So A and A gets cancelled over here, so you will have W is equal to A by C plus the quantity BC minus AD divided by C square. We can take C common, right? So we will have C square Z plus D by C, right? Okay. So we have over here W is A by C, BC minus AD, C square Z plus D by C, right? Okay. Now, how can we say that it is formed of elementary transformations? Well, let's start with Z. Okay. Now let's translate it. So we'll have Z plus D by C, right? Okay. Now let's take its inverse. That is inversion. You will have 1 upon Z plus D by C, right? Now let's magnify it. So magnification, we will have BC minus AD divided by the quantity C square Z plus D, right? D by C, right? Here the magnification factor is this, right? Alpha is this, okay? And when you take it is of course magnification plus rotation, because I forgot to tell over here A, B, C, D belong to complex number, right? Since these are complex number, this is a complex number, hence it has magnification plus rotation both, right? Okay. And then we can again take translation. So you have A by C plus BC minus AD divided by the quantity C square Z plus D by C, right? Hence it is hence bilinear transformation is composed of elementary transformations, hence proved, right? And one more thing here, BC minus AD shouldn't be equal to 0. Why should not be equal to 0? Because if it will be equal to 0, then this expression will become 0, which means that W will be equal to A by C, that is a constant value. So if W is a constant value, then it does not make any sense. Why? Because then what kind of transformation is that? There is no transformation in that, right? Hence it means that basically if W is equal to 0, that is if there are infinite points in X and Y plane, it will just end at one point. It will be just mapping to a single point in UV, right? So there is no kind of transformation in this, right? Okay. Hence AD minus BC minus AD shouldn't be equal to 0, right? Hence this is the basic idea of bilinear transformation. Now let's see some question to understand it, right? Okay. Now there's something called a cross ratio. Cross ratio, right? So let's understand this. If bilinear transformation transforms the points, suppose if it transforms the point Z1, Z2, Z3 into the points in W plane as W1, W2, W3, then the relation between W and Z is given by cross ratio W minus W1 times W2 minus W3 divided by the quantity W1 minus W2 times the quantity W3 minus W is Z minus Z1 times the quantity Z1, Z2 minus Z3 divided by the quantity Z1 minus Z2 times the quantity Z3 minus Z, right? Okay, it is a big expression, but don't worry, you have to just remember any one of them and you can just find the second one easily, right? Because they both follow the same pattern, right? So from this you can find the w as a function of z, right, easily. Okay, how can you prove it? Well, proof, we know that w is equal to az plus b divided by cz plus d, right? Okay, hence w1 is equal to az1 plus b divided by cz1 plus d, and so on. We can find w2 and w2 similarly. Just replace z1 by z2 and z3 and z3 and I mean z by z3 for w3. Okay, and just find the difference, w1 minus w minus w1, w minus w1 minus w2, w3 minus w, and you will, when you will put the values, the substitute the values, you will get the expression in this. It is very easy, you can do it. If I have written, I can tell you the expression, but I guess it is not necessary, right? You can just prove it very easily. Just find w minus w1, you will get some value. W1 minus w2, you will get some value. W2 minus w3, you will get some value. W3 minus w, you will get some value, and when you substitute it into this format, you will get this expression only. Okay, just try it as homework, right? So try to prove it once. Okay, so let's erase this and let's move to something called as invariant or fixed point. What is an invariant or fixed point? Invariant or a fixed point? Well, suppose there's a point in x plane like this. Suppose 1 comma 2, right? In xy plane, z plane, that is. After transformation, the point is still at 1 comma 2 in uv plane also, that is w plane. Then such kind of such kind of points are called invariant points or fixed points. So in such cases, f of z is equal to z, right? For those points. Okay. So for example, if we have to find the invariant point in the curve z minus 1 divided z plus 1, this is w, then what we do is that we set it equal to z itself, right? So when you set it equal to z, you get z minus 1 is equal to z square plus z. So we have z square is equal to -1 and z is equal to plus minus iota. So this is the invariant point. Okay. So if you substitute it back over here, suppose I, if suppose you substitute z is equal to I, so you have I minus 1 divided I plus 1. Rationalize it. So it is equal to I, right? And if you substitute negative I, you will again get negative I. So it means that fz is equal to z in this case. Not for all values, for finding the invariant points. So there are two invariant points in this case. Understood? Okay. So now let's move to questions, I guess. Let's see them. So let's do a question now. Find the bilinear transformation which maps the points 2, I, -2 in z plane to the point 1, I, -1 in w plane. Okay, so this is z plane, this is w plane. Okay, so we have z1 is equal to, z2 is equal to I, and z3 is equal to -2, and we have z, and we have w1 is equal to 1, w2 is equal to I, and w3 is equal to -1, right? Hence we will use the cross ratio w minus w1 into w2 minus w3 divided by the quantity w1 minus w2 into the quantity w3 minus w is equal to z minus z1 times the quantity z2 minus z3 divided by the quantity z1 minus z2 times the quantity z3 minus z1, right? I know it is very much confusing, but if you once prove that theorem, which I have told, not theorem, just prove the method that how we got cross ratio, which I have given as homework, then you will easily understand that how it works, right? That is why I have not given the proof. I have told the method. It is very simple. Just do the calculation part on your own. You will see that it is very simple, right? It is nothing difficult over here. Okay. So yeah. So we have this expression now. Just substitute the values. You have w minus 1 times the quantity w2 minus this quantity, that is I plus 1, divided by the quantity w1 minus this 1 minus iota times the quantity w3 minus w is z minus 2 times the quantity z2 minus this I plus 2 divided by the quantity z1 minus z2, it is 2 minus iota times the quantity z3 minus 2, sorry, z3 is equal to negative 2 minus z, right? And you can easily solve it, I guess, right? You can solve it right now. You can easily find a relation. Let me show you also. So I should write this expression over here. W minus 1 divided W plus 1 times the quantity I plus 1 divided by I minus 1, right? I just took negative sign common and multiplied it over here, is equal to Z minus 2 divided by Z plus 2 times the quantity I plus 2 divided by I minus 2, right? Okay, so now let's erase. Now 1 plus I divided by negative 1 minus I, it is equal to 1 plus I whole square divided by the quantity 1 minus I whole square, which is equal to negative 2, right? Because here we have a negative sign, and when you square it you will get 2i, right? So you will have negative I over here. So W minus 1 divided W plus 1 is multiplied by negative I, right? This is equal to Z minus 2, Z minus 2 divided Z plus 2, right? And again I'm saying, please watch the complex analysis one shot if you're getting any confusion, right? Because you have to learn the complex analysis first of all, then you can only understand them, right? These concepts times times the value, means times this expression I plus 2 divided I minus 2, right? So I plus 2 divided by I minus 2. So again you can take negative sign common, so you have 2 minus iota, 2 plus iota, 2 plus iota, 2 plus iota, right? So you have 2 plus iota whole square divided negative 2, that is, it will be 4 minus I square, that is 5, right? So it is equal to 4 minus 3 plus 4i divided by negative 5. So we have 1 plus, sorry, 4 minus 1 it will be, right? I square is equal to negative 1. So it is equal to 3 plus 4 iota divided negative 5, right? So this we can write it as 3 plus 4 iota divided by negative 5. So this and this will become positive. Okay. So we have W minus 1 divided by W plus 1 is equal to the quantity Z minus 2 divided by Z plus 2, right? 3 plus 4i divided by 5i, right? Now we have W1 minus W minus 1 divided by W plus 1 is equal to Z minus 2 divided by Z plus 2 times the quantity 3 by 5i plus 4 by 5, right? But we don't need to do this, okay? Because we can just multiply these stuffs, right? Easily. We can just multiply I in denominator and numerator, so you will have negative over here, and here you will have, what is I times I? It is equal to negative value over here and I over here, right? Correct? So we have 4 minus 3i. 4 minus 3i, right? Correct? So we have 4z minus 3iz minus 8 plus 6i divided by 5z plus 10, right? So it is equal to 4z minus 8 plus, minus 3iz plus 6i, or we can take I as common. So we have minus 3z plus 6 over here I, right, divided by 5z plus 10, right? So it is W1 minus this quantity. Okay. Now how we can solve for W over here? Well, if you remember, you know something called componendo and dividendo, right? If A by C is equal to A by B is equal to C by D, then we have A plus B divided by A minus B is equal to C plus D divided by C minus D, right? If you remember componendo and dividendo, right? So just do that. So you will have W, that stuff. First of all, you will add. So we'll have 2W divided by the quantity this minus this. It is negative 2. Hence again we will add numerator and denominator. What we will have? 9z plus 2 plus I times the quantity negative 3z plus 6 divided by the quantity. What we will get? We will have over here this expression 4z minus 8 plus I times negative 3z plus 6 minus this expression minus 5z minus 10, right? Of course, this is the calculation part, and I hope so that it is getting a bit lengthy, but you should try the calculation on your own, right? This is just for an example, right? So it is equal to 9z plus 2 plus iota times negative 3z plus 6 divided by the quantity negative z minus 18, right? Just see the calculation, plus I times negative 3z plus 6, right? So now let's erase this thing and let's evaluate it further. Okay, so what we had got over here, plus 6, right? So this and this gets cancelled and this plus, okay, so we just multiply both sides by negative 1, so we will get w is equal to 9z minus 3i, that is 9 minus 3i times the quantity z plus the quantity 6i plus 2 divided by the expression z, that is 1 minus 3i z plus the expression 18 and over here minus 6. So I times, that is we can simply write it over here, this will become 6i minus sign, so we will have 18 minus 6i, right? So this is the value of w, right? Now you can simplify it further by dividing both sides by, means the numerator and denominator by 3 minus I, right? Just divide it and you will understand on your own, right? So I guess I've written it correctly. Yeah, I guess over here it will be a positive sign. Yeah, because of course if negative sign will go inside, then it will become positive, right? So 9 minus 3i z plus 6i, yeah, correct. Okay, now you can take this common numerator and denominator and divide it, and if you simplify it further, you will get w is equal to 3z plus 2i divided by iz plus 6. Now this is your job to do. You just take 3i common and then evaluate it. You will get this expression only. Just give it a try. You will understand that this is much more simpler than this, right? Because it looks a bit messed up, but this looks better, right? So both are correct, but still it is in simplified form, so it looks better, right? Okay, there's another method also to do such kind of problem. Like what you can do is that you know the value of w1, that is z1 z2 z3, right? So you put the value az plus b cz plus d, w1 as az1 plus b divided by cz1 plus d, and w2 as a z2 plus b divided by c z2 plus d, and for w3 also, right? So for example, if w is equal to 1, so 1 is equal to 2a plus b divided by the quantity c 2c plus d, right? Like this. And when w is equal to I, then I is equal to ai plus b divided by ci plus d, right? And so on and so forth. So you will get three equations, right? So for example, you have got three equations, right? So in that you can express the variables in terms of one variable then, right? For example, if x plus y is equal to 0, x plus 2z is equal to 0, then we have y is equal to negative x and z is equal to negative x by 2. So we have expressed the all the three variables in just one variable, right? And x is equal to x, of course, right? So suppose if in this I ask you to find the value of x plus 2y divided by x plus 10y, so 10z, right? Then in this case you can easily find the value because you know the relation. So if we know that y is equal to negative x, so x minus 2x divided by the quantity x minus the quantity 10 times x by 2, that is 5x, so it is equal to negative x by negative 4s, which is equal to 1 by 4, right? So this is how you will get over here also when you will substitute it. If you will substitute all the three equations, you will get all the equations in terms of one variable, and then you can just substitute it over here and you will get your desired result. Okay, right? So let's erase this now and let's move to another question, right? So let's erase this. So let's discuss this last question. Let f of z be a bilinear transformation such that, now it is something interesting, f at infinity is equal to 1, f at I is equal to I, and f at negative I is equal to negative I, right? Okay, so this is which we are given, and find the image. Yeah, so we are given find image of the unit disk z belongs to C such that mod z is less than 1 under f at z. Okay, so we have to find this. Let's see solution. Okay, so now this is a tricky question because here there's something interesting involved over here, and we have a point infinity. So basically z1 is equal to infinity and z2 is equal to I, z3 is equal to negative I, right? w1 is equal to 1, w2 is equal to I, w3 is equal to negative I. Let me recheck the question, the values are correct or not. Okay, I have to check that. Okay, this is I and this is also I. Okay, yeah, okay. So w minus w1, what is w1? It is equal to 1, okay, times the quantity w2 minus this is 2I, okay, divided by w1 minus this quantity 1 minus I, right? w3 minus w, right? This is equal to, now what is z minus z1? Well, it is approaching towards infinity, so we have z minus z1 times z1 minus z2, sorry, z2 minus z3 divided z1 minus z2 times the quantity z3 minus z. Now we all know that z1 is approaching towards infinity, right? So just take z1 common, so z1 taken as common, we have z by z1 minus 1 multiplied by z2 minus z3 divided by z1 times the quantity z1, sorry, 1 minus z2 by z1, z3 minus z, right? Okay, z1 and z1 gets cancelled, and as z1 tends towards infinity, this expression tends to 0, so this is tending towards negative 1 and this is tending towards 1, right? So whenever you see infinity, just try to make the denominator 0 in this case, in that case. Okay, so you have negative, so this we have to just evaluate negative of the quantity z2 minus z3 divided by z3 minus z, right? So we will get from here negative z2 minus z3. What is it? What is z3? Z3 is equal to, I mean z2 is equal to this and this, so it is 2I divided by the quantity z3 minus the quantity z. So this will become positive and this gets cancelled. So we have w minus 1 divided by I minus 1 is equal to quantity 1 upon negative 1 upon z plus iota, right? Now from this we know that modulus of z is less than equal to 1. Hence we need to express z in terms of w, not w in terms of z over here, because if we will express w in terms of z, then it will become very difficult, right? So if we express it, then what we will get? Well, I am writing the final result only. We will get over here z is equal to 1 plus w divided by 1 minus w, right? Okay, of course you should check the calculation once because I am just doing it right now. I'm not sure if it is correct, the calculation are correct, but the result will be this. Okay, so just check the calculations once. Okay, so z is equal to this. Now we know that this we are asked that this is a disk. Okay, so it is a disk. Just a minute. Yeah, so it is a disk with modulus of z this, and it is centered at 0. So it looks like this. Sorry, it will look like this. I mean it looks like this. This xy. So mod z is equal to, is less than 1. Hence we have to image this region, right? Mod z less than 1, right? This is the z plane. So when you do this, what you will get? You will get mod of 1 plus w divided by 1 minus w is less than 1, just using this condition. So we have 1 plus w less than mod of 1 minus w. Now we know that w is equal to u plus iv, right? So from this you have 1 plus u plus iv mod less than 1 minus u minus iv, right? Mod, right? Now just square both sides. When you square it, you will get 1 plus u whole square plus v square less than 1 minus u whole square plus v square. V square and v square gets cancelled. When you open this, you have 1 plus 2u plus u square less than negative 2u plus u square. This and this gets cancelled. This and this gets cancelled. 1 and 1, everything gets cancelled. So u is less than 0. So this is the region. This is the image in W plane. Hence, it looks like this. V u. So this is u is equal to 0. U is equal to 0. So this is the region in W plane. This region is the transformation of this. This is the image. If it was greater than 1, then we would have got this region, right? It is excluding this u is equal to 0 line. Okay. So this region. So I hope so that you enjoyed this lecture. If you did, then please do like, share, subscribe my channel, and to support this video. And of course, please do check out the one shot of complex analysis too. And I hope so that this much is enough for understanding conformal transformations. And soon, maybe in 1 or 2 days, I'll be uploading the one shot of the complex integrations. So please do subscribe this channel. Bye bye. Take care.